marine fungi can be trained to degrade plastic pollution. Plastic waste is one of the biggest threats to marine ecosystems today. Every year, millions of tons of plastic enter the ocean, creating massive pollution problems and killing marine organisms. This waste does not simply disappear. Instead, it breaks down into microplastics, which spread through the water and harm marine life. Scientists have long searched for ways to reduce the impact of plastic pollution, but most existing solutions struggle to degrade plastic efficiently. Now, researchers at the University of Hawaii, UH at Manoa, have made a remarkable discovery. They have identified marine fungi that are capable of breaking down plastic. Even more impressively, they found that some of these fungi can be trained to consume plastic faster. The research could initiate new ways of cleaning up the ocean and tackling one of the most pressing environmental challenges of our time: plastic waste and its lasting impact. Plastics are widely used because they are durable, lightweight, and cheap. These same qualities, however, make them a persistent environmental hazard. Unlike organic materials, plastic does not decompose naturally. Instead, sunlight, heat, and physical forces break it down into smaller pieces. These microplastics then spread throughout the ocean, entering the food chain and accumulating in marine organisms. Plastics can also release harmful chemicals such as phthalates and bisphenol A, which disrupt marine ecosystems. Animals often mistake plastic for food, and its ingestion leads to malnutrition and starvation. With an estimated 1,050 garbage trucks worth of plastic entering the ocean each year, finding a way to eliminate this pollution is crucial. Untapped potential of marine fungi. Plastic in the environment today is extremely long-lived and is nearly impossible to degrade using existing technologies, said Ronja Steinbach, who led this research as a marine biology undergraduate student in the UH Manoa College of Natural Sciences. Our research highlights marine fungi as a promising and largely untapped group to investigate for new ways to recycle and remove plastic from nature. Very few people study fungi in the ocean, and we estimated that fewer than 1% of marine fungi are currently described. Fungi are known for their ability to break down tough organic materials. Many species can digest substances that other organisms cannot, such as wood and chitin. However, most studies on fungi and plastic degradation have focused on land-based species. The UH Manoa team wanted to see if marine fungi had similar capabilities, testing marine fungi for plastic degradation. The researchers collected fungi from various sources, including sand, seaweed, corals, and sponges in Hawaii's nearshore waters. They then tested these fungi to see if they could break down plastic, specifically polyurethane, a common material found in foams, adhesives, and medical products. Fungi possess a superpower for eating things that other organisms can't digest, like wood or chitin. Professor Amend heads up the lab collection for their ability to digest with marine biology graduate Professor Anthony Nguyen from Pacific Biosciences Research The researchers placed polyurethane in petri dishes showed a clear ability to degrade various types of fungi and observed their interactions. The team then took the fastest-growing fungi and exposed them to polyurethane over time to see if they could evolve to consume plastic even more efficiently. The fungi adapted quickly, with some increasing their feeding rate by 15% within just 3 months. The results of the experiment were astonishing. We were shocked to find that more than 60% of the fungi we collected from the ocean had some ability to eat plastic and transform it into fungi, said Steinbach. It was very exciting to see that in just 3 months, a relatively short amount of time, some of the fungi were able to increase their feeding rates by as much as 15%.
Plastic also raises hopes that further research could enhance their efficiency even more. Hawaii's unique role in plastic research. Hawaii's location in the North Pacific subtropical gyre makes it a prime spot for studying plastic pollution. Ocean currents bring plastic waste from all over the world to Hawaii's shores. Nearby, the Great Pacific Garbage Patch contains massive amounts of plastic debris, making it a major environmental concern. Because of this, Hawaii serves as an ideal natural laboratory for researching plastic degradation. The fungi collected from these waters may have evolved unique abilities to break down plastic due to their constant exposure to pollution. This makes them valuable candidates for future biotechnological applications. Expanding the research, the Manoa team is now looking to expand their research. They want to test whether these fungi can degrade other plastics, such as polyethylene and polyethylene terephthalate. These materials are even more resistant to decomposition and are some of the most common plastics found in the ocean. Additionally, scientists are working to understand the molecular mechanisms behind fungi's ability to break down plastic. By studying these processes at a cellular level, they hope to improve plastic degradation techniques. The next step is to collaborate with other experts to develop practical solutions based on these findings. We hope to collaborate with engineers, chemists, and oceanographers who can leverage these findings into actual solutions to clean up our beaches and oceans, said Steinbach. If scientists can refine these fungal processes, they could potentially be used on a larger scale. Marine fungi could become a key tool for reducing plastic waste, both in the ocean and on land.